This is question number 18 on the November 2013 higher calculator paper. This particular question says ABC is an isosceles triangle. So that fact is important to note. The question wants us to work out the area of the triangle, and they want us to give the answer correct to 3 significant figures. It also indicates that the diagram is not drawn to scale, which is important, right? So you can't take any measurements from the diagram itself. What I need to do is to work out the area of this triangle, and actually there's several methods or techniques that I could use to do this. I'm just going to choose one of them, one which I think is maybe one of the most obvious to use. The formula to work out the area for triangles, so area of a triangle is half times the base times the height. And in this case, we know that the base of this triangle is 12 centimeters. There it is. So if I could work out the height of this triangle, I could use the formula for the area of a triangle and work out the area of this triangle. Now the height of this triangle is this bit here. And if I draw a line down the center, and because it's an isosceles triangle, this line is perpendicular to the base, it's at right angle to the base, and it cuts the triangle into 2 equal sections. So that's 6 and that's 6, half of 12. So what I've done is I've created a right angle triangle, which I know the base of this right angle triangle, and I know the base is 6 centimeters. I know this angle here is 54 degrees. This is a right angle, and that's the height. And I want to work out the height of this triangle. So I'm going to use trigonometry to help me with that. Relative to the angle 54, this height is opposite that angle. That's the hypotenuse, and that is adjacent to the angle. Okay, now I'm thinking about which ones do I need. I do not need the hypotenuse, and if I think about SOHCAHTOA, S-O-H-C-A-H-T-O-A, which ones of those actually has O and A in it? It's the tan, and so I'm going to use that to help me work out the opposite side. So H is going to be, if I cover up the O, that sort of helps me. I want to do tan of the angle, tan of 54 degrees, and I'm going to times that by the adjacent side, which is 6. Okay, that's what I need to do to work out the height of that triangle. I need to go to my calculator, make sure my calculator is in degrees mode, and I need to do this calculation. So tan of 54, close the brackets, times that by 6, and that's going to equal the height of this triangle, which is 8.25829. I'm just going to say ... because it actually carries on. I'm going to keep that number on my calculator. So to work out the area of this triangle, and if I just move the sheet a bit further up, so to work out the area of triangle, I'm going to do half times the base, which is 12. So the base of the whole triangle, the original triangle, is 12, and I'm going to times that by the height, which I just worked out, which is 8.25829, and I still have that number on my calculator. I'm going to times it by 12 and then divide by 2, half in it, and that gives me 49.549. I'll write that down. 49.549. I'll just do that. And the question wants me to give this answer to 3 significant figures. So counting from the front, 1, 2, 3, chop it off there, and my answer is going to be 49.5, and it's all in centimeters, so it's going to be 49.5 centimeters squared. If I just raise this up and show you the answer space, what goes in the answer space is 49.5, and centimeters squared is already included. If I show you all the workings for this question, it is a pretty straightforward question, which if you're working at this level, you should be able to work through it, use the simple trigonometry, right, and be able to get full marks in this. As I said, there's several different ways of actually getting the answer to this. If you look at the mark scheme, it offers 3 different alternatives. Look at them, make sure you understand it, and make sure you have a method which works and that you're comfortable with.